Hi, today I want to share with you this website, a very interesting website. The name is Talking Electronics. It's an Australian website by Colin Mitchell. Colin Mitchell, back in the 80s, used to have an electronics hobbyist magazine, the same name, Talking Electronics. And with every issue, there is a few circuits and kits to be built. So you have here all the issues, which I believe are 15. Yeah. So this is the magazine, and then you have small projects that you can build yourself. Back in the time, those comes as kits attached to the magazine, and I thought to try and build one of these projects. The schematic is there, everything is there. So I thought to build one and to test it and see how it works. And then I thought also to use a PCB software to design the PCB and order it and then build it actually on a PCB. So I'll leave a link to this website in the description below. Also, you can find a few interviews done with Colin Mitchell. I'll leave a link to that. Also, it's in Dave Jones' EEVblog YouTube channel. Actually, this is how I come across this website. And then you can see and hear the history of this magazine and how it was altogether built in back in the 80s. So the circuit I chose to build is, if I can find it, is the electronic dice. It's a very famous circuit. There is many videos in the YouTube about this circuit. Many people have done that before, so I thought to give it a try myself. Yeah, the circuit is here, should be somewhere here. Yes, this one. So this is the circuit. Now, I always wanted to have an electronic dice. I love playing board games, and I thought maybe this can be useful. The only thing is that the board games I play use two dices, so maybe I'll do a dual dice when I design the PCB. We'll see. So this is the circuit, and then although the dice is the numbers and on each face are from 1 to 6, we have here 7 LEDs. We have 7 LEDs, and that is to mimic the exact face of the LED, of the dice. So if you have, for example, 3, it will lit this 3 LEDs. If you have 5, then there is 4 LEDs in the corners will be lit plus the one in the middle. If you have 1, it will be only the one in the middle, as you can see here in this small picture here. The circuit is explained here. It's very easy and simple circuit. It's based on two chips, the 555 timer and the decade counter, the 4017. And the 555 timer trigger the clock of the decade counter for a certain time, and this time is basically defined by this capacitor, and when you touch the plate, you will basically actually when you touch the plate, you are charging the capacitor, but how long you are touching the plate will define how much you are charging the capacitor, and then how long the LEDs start to blink, for how long, and then slow down until they rest. and display the number. We'll see all that in the breadboard. First, I will try to build this circuit in a breadboard to test it. Okay, so the circuit is now built on the breadboard, and as you can see, we have here the 555 timer, we have here the decade counter, and then we have the 7 LEDs here. So this is the oscillator part of the circuit with the capacitor and this transistor and the 555 timer. So the circuit is already connected to the power supply with 9 volt output, and let's power now the circuit and see how it behaves. So as soon as we power the circuit, we have 3 LEDs lit here, and then we'll touch the plate and see. So as expected, LEDs start to blink, slow down to a complete rest, and then it displays the number. So the circuit works fine. What we can do now is we can probe some node and see the behavior of the capacitor, maybe the transistor, and then the output of the 555 timer. So basically what we are doing when we touch the plate is closing the loop, closing the circuit, and the resistance of the skin. The capacitor basically will charge through the resistance of the skin, and since it's high resistance, the capacitor will charge slowly. So this is why it takes some time for the capacitor to charge, and then it will discharge, triggering the clock. Then the 555 timer will trigger the clock of the decade counter. So as you can see, if you just touch it with a very high resistance and short time, the capacitor is charged at a certain level, but if you keep our finger, then we can see that the capacitor charge even more than that, and it takes longer time for a complete rest. Okay, so we have our oscilloscope hooked to the output pin of the 555 timer, and now we will start the circuit and see the output of the 555 timer. I'm not sure if it's visible, but we can see here, we can see a very brief pulses here. It's very difficult to trigger on those pulses, but we can see pulses here that will trigger the output of the 555 timer. So those pulses that we can see here will trigger the 4017. What we can do is we can try to single sequence maybe, and yeah. So here we have 2 pulses here. It's very clear. So here it's very clear. We have 1, 2, 3, 4 pulses here. So those pulses trigger the 4017. Okay, so I just received the package with the PCB. They looks really nice. I finally went with the GLC PCB. So this is the PCB. It's neat. I think those resistors might be very close to each other. Hope there is no mistake in the traces. And the small logo here is very nice. Okay, so we'll be now populating this PCB and hopefully it will work. Okay, so now all the components are soldered, and all chips are mounted on their respective sockets. And what we will do now is we'll power our circuit and see, hopefully it will work, and see how it will perform. So 9-volt supply, and turn on power, and we have first display of 2 and 2. Okay, so let's try and push the button, and the LEDs are blinking as expected, and we have a first draw 6-1. Let's try again, 6-5, 5-4. So the circuit is working and everything is fine. I hope you guys liked this video and all the process from building the circuit in the breadboard to the PCB. I might do the same for other circuits, choose other circuits and try to design PCB for it and test it on PCB if I like the kit. We'll see, but until then, see you next time and wish you a very good time. Bye.